and welcome to Research Bites, your daily dose of science news. Today, rice is the most widely consumed staple food in the world, feeding more than half of the world's population. We have nothing but a tiny piece of RNA or ribonucleic acid to thank for the mouthfuls of rice that we eat. In a recent study that was published in the journal The Plant Cell, researchers found that a particular microRNA is the reason we have been able to cultivate rice and harvest greater yields of the grain today. The domesticated rice varieties of today have come a long way from their wild ancestors. Wild rice produces very few grains that often fall off and onto the ground all on their own. The domesticated rice varieties, on the other hand, are short and erect with more grains that remain on the crop until it's time to be harvested. The study shows that this is because of an accidental loss of a microRNA called MIR397 during the course of breeding. When this microRNA is absent, higher amounts of a material called lignin get deposited in the stems of the plant. Lignin is found in abundance in woody plants. It lends support and rigidity to the plant, helping easy harvest of the grains without spilling them on the ground. The expression of a specific gene or group of genes is controlled by a particular microRNA tailor-made to target them. When genes are expressed, they produce proteins that are needed to bring out a trait, for example, the shape of the grain. They do this by making a copy of themselves, and this copy is called the messenger RNA. MicroRNAs, on the other hand, do not code for any genes, and instead they seek specific messenger RNAs and bind to them by hydrogen bonds. These bound messenger RNA will either be destroyed or suppressed from producing any proteins. The researchers extracted and compared microRNAs from selected varieties and found that a particular microRNA was present in significant quantities in the wild type but was absent in other domestic ones. This microRNA is thought to have evolved recently only in the rice genus. It targets messenger RNAs that targets a group of enzymes called lacases. When lacases are blocked, the production of lignin is suppressed. The researchers also observed that this gene suppression is amplified and fortified by an enzyme that's not usually found in plants. This enzyme makes copies of the microRNA pieces that are broken off from the target messenger RNA, which further seek more messenger RNAs to bind and destroy them. This amplification leads to the powerful suppression of gene expression. To cap it off, when MIR397 was expressed artificially in domesticated varieties, they appeared sickly with weak stems and other characteristics, proving how important it was to lose this RNA altogether in the evolution of domesticated varieties. In one stroke, they were instantly de-domesticated. Rice breeders can use this microRNA as a molecular marker to enhance rice yields. Also, this is a good candidate for genetic engineering to further develop the crop. A growing population like India's needs all the help it can get to enhance the production of food grains and meet the food demands. Luckily, in the process of domestication, the loss of a small microRNA has resulted in such significant differences that are allowing scientists to improve the crop so very much. Thank you for listening. Don't forget to like, share, and follow. This podcast was brought to you by Research Matters, a SciComm initiative by Gubi Labs. For more science-based stories, podcasts, and news, log on to our website www.researchmatters.in.